Hi everyone, I would like to talk on the topic chemical aspect of enzyme action. So let's start. Substrate are small molecules or small groups of large molecules. On the contrary, enzymes are macromolecule substances. Hence, the substrate interact directly with a definite small portion of the enzyme called as an active site. The nature of active site, that is the amino acid composition and sequence, and also of the cofactor that enters its composition, has been established for a number of enzymes. The change in activity that arises as a result of chemical modification of a protein makes it possible to reveal the functional group of the active site. Information on its structure is provided by optical and spectral method, and also by the X-ray structural analysis of complex of enzymes with competitive inhibitors, whose structure is similar to the substrate structure. The varieties of amino acid residues of the enzyme and of the atomic group of the cofactor determines the polyfunctional of the active site. Inability to bind the substrate and catalytic activity. An enzymatic reaction involves many steps and proceeds through a number of chemical conversions. Thus, for example, the active site of esterases contains serine, which undergoes acylations at any intermediate stage of the process. The substrate undergoes the concentrated action of various groups of the active site. The cofactor is the magnesium ion. An especially important role is played at the active site by the SH group. The enzyme is inactivated by iodoacetamide and iodoacetate. In the presence of magnesium ion and both substrate, the SH group is protected from the action of blocking agent. The SH group is attached through a hydrogen bond to one of the main group of the enzyme. The facile transition of the protein in the hydrogen bond acid-base system impart high catalytic activity to this system. The electron transfers in the substrate and groups of the active site. Essential in the formation of enzyme-substrate complex is the precise mutual orientation of the functional group of the enzyme and substrate or modifier. The active site is naturally chiral and thereby stereospecific. It has been found with the aid of label atom that reaction of molecule of the type CAA-BD occurs on the surface of the enzyme in an asymmetric manner. This refers, for example, to transformation of amino malic acid to glycine. A direct X-ray diffraction study of complexes of lysosome with inhabiting analog of substrate, polysaccharide, has shown that the ligand is incorporated into an active present in the lysosome globules and comes into contact with several functional groups of the enzyme. The structure of such a complex is dissipated. The fact of the substrate incorporation has been established for other substrates. For a number of enzymes, there has been extensively studied the sequence of chemical conversion, that is, reaction step taking place at the active site of an enzyme-substrate complex. For instance, Burstein and his colleagues have investigated the chemistry of aspartate aminotransferase. This enzyme contains pyridoxal phosphate as a cofactor. Pyridoxal phosphate added to a protein reacts with the substrate and amino acid, chemically forming aldyl amine. A pyridoxamine form of the enzyme is formed, which reacts with another keto acid containing R2 in place of R1. The starting enzyme being regenerated and new amino acid forming. Such is the scheme of transamination, the transfer of the amine group. Practically all reactions that are catalyzed by enzyme can also take place without enzymes, but at much lower rate. Therefore, one can model the steps of an enzymatic process in low molecular weight concurrent system. And the another topic I will be talking on conformational properties of enzyme. So let's begin. Conformational lability of a protein makes possible its interaction with substrate and other ligands. In some conformation, the protein binds the substrate more effectively. Simultaneously, there takes place a selection of conformation of the substrate. The conformation of the protein and substrate that are selected into the enzyme-substrate complex are those which are structurally complementary to each other, thus providing the optimal value of the free enzyme of interaction, which are structurally complementary to each other, thus providing the optimal value of the free energy of interaction. During the formation of an enzyme-substrate complex, the conformation of the protein and substrate fits together. The conformation changes involved lead to the structural fits between the enzyme and the substrate. The conformational effects determine significant changes in entropy during the formation of an enzyme-substrate complex. A decrease in entropy that occurs during the fitting interaction can be compensated by a decrease in enthalpy. A physical analysis of event of this kind requires that phenomenon that occurs in the water environment may be taken into account. At the turn of the century, Emil Fischer proposed the lock and key model for the treatment of enzyme-substrate interaction. The enzyme and the substrate possesses rich structure, the active site of the enzyme being structurally complementary to the substrate so that it fits with the substrate in much the same manner as a key fits into a lock. A number of facts contradict this model. The enzyme-substrate interaction is probably not a static one, but it's rather a dynamic interaction. Koshland advanced an induced fit theory to account for the specificity of the enzyme-substrate interaction. Postulates of this theory, which are designed primarily in an attempt to explain the specificity of enzymes that catalyze bond transfer reaction. 1. The substrate causes changes in the geometry of the enzyme as it fits into the active site. 2. A delicate orientation of catalytic group is required for enzyme action. The substrate induces this proper orientation by the change it causes its geometry of the enzyme. Of course, the induced fit theory covers also those cases which involve the alteration of the conformation of the substrate rather than the enzymes or of the conformation of both. The main idea of the theory is determinative role of the conformational liability of the interaction molecules for enzymatic catalase. A number of facts really serve as an indication of conformational changes of enzyme upon their interaction with substrate. In the presence of substrate, some enzymes became more rigid, others on the contrary and are made more liable. They are denatured more easily upon heating. Substrate induce the dissociation of the glutamate dehydrogenase and hexokinase into subunit. The substrate affects the reactivity of the amino acid residues of the enzyme. The absorption spectrum of the chymotrypsin is changed when it interacts with the substrate, and these changes may be treated as being caused by the change in conformation. The change in conformation are seen in the luminescence specs of both aromatic amino acid residues and disorbate on the protein. Spectropolarimetric methods have been revealed change in an alpha helicity that arises upon interaction of enzyme with substrate, coenzyme and other ligand. Information on conformational changes in enzyme-substrate complex is also furnished by the ERP spectrum of enzymes containing paramagnetic label, NMR spectrum, etc. Thank you.